Good morning, students. Here we are continuing with our chapter vectors. Vectors. That means the chapter 22. Okay. So in the first chapter, we have introduced what is vectors and some properties. What is the magnitude and also the scalar multiplication of a vector, position of a vector, and how to add and subtract vectors. Okay, so all that types of properties of vectors has been discussed in the previous chapter. So in this chapter we have discussing the more properties. That means the scalar product of vectors and vector product or cross product of vectors has been discussing in this chapter. Yes, we are going to discuss about that two ones. The scalar product and the cross product or the vector product. Okay, so this is going to study in this chapter. So, for as an introduction, it has been given. One of the ways in which two vectors can be combined is known as the scalar product. Okay, so scalar product is the name, okay, and that is a combination of vectors. We can combine two vectors. Yes, this is just a name, scalar product. And when we calculate the scalar product of two vectors, the result, that means is rather it is a scalar rather than a vector. So we as we combine these two vectors, the result of this combination of two vectors is a scalar one. Okay, that not a vector one. That means scalar one means it has only magnitude. So we get a scalar product when we combine two vectors. That is the scalar product. Okay, that is the scalar product. So in this unit, you are going to be learn about how will you calculate the scalar product and the some geometrical applications. So the definition of the scalar product. What do you mean by a scalar product? Okay, so two vectors A and B have been drawn in the given figure, and we have drawn the two vectors so that the tails are at the same point. What is the tail? Yes, that the end points are the same. Okay, end points are the same, and the angle between the two vectors are labeled as theta. Okay, so the two vectors has been labeled as theta, and so that is the figure means. So the given figure has, yes, two vectors has been given, yes, A and B. Okay, and the theta is the angle between A and B, and these two vectors have the same end point, starting point. Okay, and then what does defines? The scalar product defined as the scalar product of A and B is defined to be A dot B. Okay, this is how to be read A dot B. That okay, A dot B is equal to modulus of A into modulus of B into cos theta. Okay, A dot B is equal to modulus of A into modulus of B into cos theta. That is, it is the dot product. Scalar product is also known as dot product. Okay, so A dot B, it is read as A dot B, and here there's the modulus of A, that is the modulus or magnitude, modulus of B, magnitude of B, and also theta is the angle between A and B. This is the scalar product. This is the definition of a scalar product. A dot B is equal to modulus of A into modulus of B into cos theta. The given, yes, the cosine of the given angle between A and B. Okay, yes. And here I have been given an example for you. Here's how will you calculate. Okay, here the picture gives the vector A and B is given, and 60 degree is the angle theta. And suppose here we have, suppose A has modulus 4. A has modulus, the magnitude of A is 4, and the magnitude of B is 5 and the given angle is 60 degrees. So A dot B, or the scalar product or the dot product, is A dot B equal to modulus of A into modulus of B into cos theta. That is 4 into 5 into cos 60 degree. You know the yes, what is cos 60 degree? Cos 60 degree is 12. Yes, from the scientific calculator we get the angles 12. Okay, and 4 into 5 into 12 is 10. So we get a scalar answer. It has only magnitude, it does not have any direction. So it is a scalar product. Okay, that is the answer. Yes, that is the example for you. And there have been some properties. The scalar product is commutative. That means A dot B is B dot A, and also it is distributive over addition. A dot B plus C is A dot B plus A dot C, and B plus C dot A. Left distributive and right distributive is. And also we can say two vectors are perpendicular. Okay, yes, if for two perpendicular vectors, yes, if vectors are perpendicular, then yes, A dot B is 0. So easily we can identify if the vectors are perpendicular or not. Yes, by finding the dot product. A dot B, if A dot B is 0, then the vectors are perpendicular to each other. Okay, and also if I and j k, you know the unit vectors. Yes, it has direction in xyz axis. Then we can say I dot j is 0, I dot k is 0, and j dot k is 0. And I dot I, j dot j, and k dot k is 1. Okay, yes, that is given there. These all properties, yes, you have been studying for doing problems. Yes, you can do problems using these two properties. So you just yes, you just have to be familiar with this one. And the last property is if A is A1I plus A2J plus A3K. That means these are the points in the XYZ plane. Okay, and B is also B1I plus B2J plus B3K. Then we can say A dot B as, okay, we can say A dot B as A1 into B1. The first, yes, the first element of the, yes, A1 B1 plus A2 B2 plus A3 B3. So we can directly find the dot product or scalar product. Okay, and here is an example for also for you given. If A is 6I plus 3J plus 11K and B is 12I plus 4K, then here J component is 0. The last second the J component is 0. So A dot B is, okay, 6 into 12 plus 3 into 0 plus 11 into 4. So we get 116 as the answer. Okay, yes, this is the example, and you have been given exercises. Yes, there has been you just work out this exercises also. Okay, and the next are some applications of scalar products. That means how will you use, okay, scalar product to test whether two vectors are perpendicular. I have been just given for you that if A dot B is 0, we can say that yes, these two vectors are perpendicular. So this is using here. That is, a common application is to test whether the vectors are 0 is from the definition A dot B, okay, modulus of A into modulus of B into cos theta. So if both vectors A and B are non-zero, and we can find A dot B as 0. Yes, we have just familiarized with the property. So if two vectors are perpendicular, A dot B is 0. So from that equation, A is equal to modulus of A into modulus of B into cos theta. You have to get A dot B as 0. So how will you get A dot B as 0? Yes, that is, we can deduce cos theta from that equation. The cos theta, if the cos theta is 0, Why you have to go to the cos theta? Because yes, a and b are non-zero, so we cannot take a and b are 0 because it is magnitude. Okay, modulus, it has to be a scalar value. So we have going to the cos theta. So if cos theta, when will cos theta become 0? When will cos theta become 0? Yes, cos 90 is equal to 0. You know that cos 90 is 0. So that means 90 degree. Cos 90 degree is 0. That means 90 degree came there. That is the angle between A and B is 90 degree. What does it means? Yes, they are perpendicular. Okay, this is how, yes, or a dot b becomes 0 because it is the product. Okay, so product becomes 0. One term is 0, that means the product is 0. This is how you get, yes, we can use scalar product to test whether the vectors are perpendicular. Yes, I think it is clear. Yes, then we have given another example. AB is given as a determinant. Okay, that is a1. You know that the coordinates 3 yes, 3 into 1 plus 2 into, yes, 2 into 2 plus 1 into 1, which is 3 minus 4 plus 1 is equal to 0. Yeah, that is given. Okay, and next, using the scalar product to find the angle between two vectors. How will you find the angle between two vectors? That is, the angle between two vectors can be find out from that definition also. A dot b is my modulus of a into modulus of b into cos theta. From that, cos theta can be find out. How will you find? Yes, a dot b by modulus of a into modulus of b. That means if we have given a and b in the Cartesian form, yes, the result is calculated as a dot b. So we can also calculate the modulus of a and b. What is modulus of a and modulus of b? Yes, it is in the xyz plane. So modulus of a is root of x1 square plus x2 square if it is an xy plane. So if it is in a 3-dimensional, we have to find the, yes, square root of the 3 squares. That means here given modulus of a is a1 square plus a2 square plus a3 square, and modulus of b is b1 square plus b2 square, root of b1 square plus b2 square plus b3 square. Okay, this is it is also easy, cos theta. That means you have to find the angle. Okay, yes, this is that. And now, sign of the scalar product. What is the sign of a scalar product? Yes, if vector a, that means we have in this chapters, we have just here also this a and a b means these all are vectors. Okay, this all cos theta here, vector a into vector b by modulus of vector a into modulus of vector b. That means, okay, in this chapters we have dealing with only vectors. Okay, so these a b c all things are vectors, are in vectors. Okay, yeah. And so this if vector a and vector b are non-zero vectors, then the scalar product vector a dot vector b, that is a dot b is, yes, a into vector b, here is b, into cos theta is positive or negative or 0. That means it was according to the angle. Okay, so we can say that a and b are non-negative. That means non-zero. Okay, so this depends upon the cos theta, the angle. Okay, so if the angle is acute, obtuse or right, according to this, yes, the sign of the scalar product is positive, negative or 0. So if theta is acute, that means less than 90 degree, yes, the less than 90 degree, the scalar product is positive. If theta is right, that means theta is right angle, then it is equal to 0. And when theta is obtuse, that is not written there, sorry, okay, if theta is obtuse, the angle is less than 0, sorry, the scalar product is less than 0. So theta is acute, it is greater than 0, scalar product is greater than 0. Theta is right angle, the dot product is 0, and theta, if theta is obtuse, the dot product is less than 0. This is the sign of the scalar product. Okay. And now the geometrical representation. Okay. Yes, there we can geometrically represent the scalar product of two vectors is the product of the modulus of one vector and the length of the projection of another in its direction. Okay, that is to be remembered. Okay, that just it was given there. Okay, what is the, you know what is the projection also, and vector, oh yes, OA and OB are vector A and B, and then modulus, we have just calculating the modulus, and OA and OB has been given, and the angle between that is theta, and PQ are the feet of the perpendicular from A, B on OB and OA, and we have taking the triangles. Okay, and from that cos theta is calculated, and AB, vector A and vector B is, we get the answer, and we have to find the projection, that is we have given the projection of vector A on B, and similarly vector B projection of vector B on A, that is the calculated. So from that result, geometrically it is interpreted as the scalar product of two vectors is the product of modulus of one vector and the length of projection of another in its direction. Okay, this is the alternative, or the geometrical interpretation. And next is the projection of one vector on the other. We know what is a projection vector. Projection of one vector on the another is given. Okay, that is the last, that is the important. Scalar projection of B, vector B on the direction of vector A is vector A dot vector B by modulus of vector A. Okay, scalar product of the vectors divided by modulus of the vector A. This is the projection of one vector on the other. Okay, yes. This is the symbol identities. As identities, you know, A plus B the whole square. So here also the vectors is the A and B are vectors. So the same result is followed. Vector A plus vector B the whole square is yes, a vector A square plus vector B square plus 2 into vector A vector B. Okay, and similarly A minus B, A plus B into A minus B, and A dot B. Okay, A dot B is 1 by 4 into vector A plus B the whole square minus vector A minus B the whole square. These symbol identities are used to to solve problems. Okay, and there has been solved problems for you to find the scalar product. Okay, yes, I think it is easy. Yes, I have been given all the yes necessary properties, and also so you just work out these problems. Many problems has been given. First is this scalar product. How will you find the scalar product is this, and how will you find the angle between the two vectors, that is given here, and the mutually perpendicular parallel lines, mutually perpendicular and parallel vectors. Parallel vectors, how will you identify it as a parallel, and also it is a mutually perpendicular, also that has been given in your textbook. Please go through that workout problems. That is, yes. So these are the main problems from this chapter. Also there has been given how to find the dot product of yes perpendicular and parallel also, and also there has been given many problems for you. Okay, workout problems and exercises has been given. Please go through that and try to solve all type of questions there, and exercise problems are very important. Okay, so thank you. That is all for today's topic, today's class. I hope all of you understood the topic. Okay, if you feel any doubt you can ask me, and yeah, that's all. Okay, thank you, students.